So this is the first part of a class. So you're going to listen to this video and take a note. You should have a note outline given to you from the class, or you can go to the website and print one off. We're talking about the length of a line segment today. By the end of class tomorrow, you should be comfortable with those three bullets that are listed. Applying the formula to find the distance between 2 points, which is the same thing as finding the length of a line segment. Recognize when to use the distance formula when you're given a word problem. And finally, applying that distance formula when proving or disproving some geometric properties. So for example, if I gave you a triangle, I could say, prove that it's an isosceles triangle. And you might use distance to show that that is true. We're going to start with two fairly straightforward examples. The first one is a vertical line, and you'll notice just like when we did midpoint in class the other day, the x-coordinates of a vertical line are going to be the same because you're the same distance left each time, and the y-coordinates will be different. So the question is, how long is this line segment? Well, I suppose we could count squares and determine that it is 4 units long. But we can also use the points to figure out that 4-unit number. And I think it's obvious if we take 6 and subtract 2, we can get 4. So we can simply subtract the x-coordinates, the y-coordinates of a vertical line to get the distance between the points or the length. Similarly, with a horizontal line, the y-coordinates are the same. And so we can count squares again, and we will get 5 squares. Or we can take the x-coordinates and subtract them, big one, take away small one, and get 5 units long. So what happens with a horizontal line if it starts to the left of the y-axis and moves to the right of the y-axis? Well, just as a bit of a reminder, we can still count squares, 4, 5, 6, 7 units long, or we could find the coordinate points of this. This left point would be -2, -4, and this right-hand point would be 5, -4. And to get the 7, we are going to take the larger x-coordinate and subtract the smaller x-coordinate. So 5 take away -2. Oh, no problem, that's the same as 5 plus 2, which is 7. More of a challenge comes when our line segment is on an angle. So I see this point 2, 1 at the bottom and 6, 4 at the top. And we need to find the length of that line segment. So I think if I was back in grade 9, I would draw a triangle and count squares and determine the side lengths by counting squares, 1, 2, 3, 4, and up the side, 1, 2, 3 units. And then I would apply Pythagorean theorem because I have a right angle triangle now, and I could figure out my hypotenuse by saying C is equal to the square root of 4 squared plus 3 squared. And I could work that out on my calculator and get the answer 5 fairly quickly. So what have we done here? To get this x answer of 4, we've looked at the x-coordinates of the point, the 6 and the 2. And 4 is really 6 take away 2. When we get the y-coordinate of 3, we're doing the same thing, looking at the y-coordinates, 4 and 1, and we're taking 4 take away 1 to get the answer 3. So if I took the general case of this and said that instead of having points with coordinates, I put in, let's say, x1 and y1 for those coordinate points, and x2 and y2 for this coordinate point, I think I could simply subtract my x's and subtract my y's to get these small lengths. When I apply Pythagorean theorem, I'm going to subtract those numbers and then square them. So from that, we can derive a formula. And the formula looks like this. subtract the x coordinates, and square the answer. That's like doing 6 take away 2, getting 4, and then putting 4 in the Pythagorean theorem. So you'll need to square it. So let's take this same example and work it out using algebra. So I'll get rid of all of my marks here, and we'll go back to the beginning. So I'm going to call the second point up here B, and this first point A. So I'm going to take the x from the B coordinate, which is 6, subtract the x from the A coordinate, which is 2, and go back and do the same thing with the y's. So 4 take away 1, 6 take away 2 is 4, 4 take away 1 is 3, square each of these, add them together, and take the square root. Now, when we take a square root of a number like 25, we typically get two answers. We get positive 5 and negative 5. This negative 5 is called an extraneous root, long form of the word extra, and for lengths and distances, we get to ignore that negative root. But in the algebra, that root will actually exist. Let's take a look at the next one. Okay, a little bit more complicated because we've got some negative numbers. So we'll take the same formula and substitute in the new numbers that we've got. Doesn't matter which point you call A and which point you call B. I'm going to call this one B and this one A. And take the x coordinates, 3 and negative 2, and subtract them. You will need a bracket because you've got a negative number. And take the y coordinates and subtract them as well. Work it out. 3 take away negative 2 is 5. Negative 2 take away negative 4 is positive 2. 5 squared is 25. 2 squared is 4. 25 and 4 is 29. And I go to my calculator and I get approximately 5.39. So this answer under the root sign is called an exact answer. If you punch that in your calculator will store all of the decimals even if you can't see it. And this answer at the end is called an approximate answer. Sometimes in math you're going to be asked for approximate answers to the nearest tenth or hundredth. Sometimes you'll be asked for an exact root and you need to be able to differentiate. I'm going to draw your attention to the definitions that you have on your note of the different types of triangles that you should have covered last year in grade 9 or in previous years to that. So you need to be familiar with those terms. So let's take a look at an example. Find the length of the sides of triangle ABC. So a very typical math question. Let's use exact roots this time. So to do this question, we're going to do the distance formula 3 times. And I'm looking at my points, and there are no shortcuts for the points. There's no horizontal lines, and there's no vertical lines. So I'm going to apply the formula, subtract the x's, so I'll call them x2 minus x1 this time, and square them, and then subtract the y's, and square them. And again, you only need to quote your formula once for every assignment that you are doing. But to memorize it, it's a good idea. So I'm going to find the distance between A and B. So in my communication, I'm going to be really clear what I'm doing here. Subtract the x's. 5 take away 2 and square it. Subtract the y's. 1 take away negative 3 and square it. Take the square root. 5 take away 2 is 3. I have to square it. 1 take away negative 3 is 4. I have to square that. 3 squared is 9. 4 squared is 16. 9 and 16 is 25. Square root of 25. Plus or minus 5, I'm going to take the positive answer 5. So I'm going to just put that number over on my grid. Do the same thing with the other ones. So, distance of BC. I'm going to do this much quicker. I'm going to start with C. 9 take away 5 is 4. I have to square that. 4 take away 1 is 3, and I have to square that. Take my square root, and notice it's the same thing that I've got over here. So that's going to be 16 plus 9, which is the root of 25, which again is 5 units long. Put that on my picture. Do my last distance from A to C. I'm going to do it in the short way again. 9 take away 2 is 7, 7 squared. 4 take away negative 3 is also 7. I square that. 7 squared is 49. 49 plus 49 is 98. And I take the square root of 98. I can call that the square root of 98. So a typical math question would say classify triangle ABC. And when we classify something, it means to give it a specific name. What we're looking for is as specific as possible. So you're going to go to the definition list that you have and figure out which one most closely resembles the question that we have. So I see very clearly here I have two equal sides. So I'm going to start by saying that this triangle is isosceles. I don't know, though, if this is a regular old isosceles triangle or if it is a right-angled isosceles triangle. From this picture, which is pretty terrible, it looks like it could have a right angle up here at the corner of B. So I have to find a way to test it, just using any math that we already know. So I suppose we could use the slope and decide what the slope is between these two sides. But I already have the three side lengths. So I'm going to look at Pythagorean theorem, which I know is c squared equals a squared plus b squared. And I want to see if Pythagorean theorem works. If Pythagorean theorem works, then it's a right angle triangle. If Pythagorean theorem doesn't work, then it is not a right angle triangle. But to classify something properly, I need to figure out what it can't be as well as what it must be, if that makes sense. So side C is hypotenuse. I think that's bigger than 5, so that would be the square root of 98, and then I have to square that, which square root of 98 squared is 98. So my left side is 98. A squared would be 5 squared, and B squared would be 5 squared. So that would be 25 plus 25, which is 50. So I can just say it's an isosceles triangle. I could also indicate that it is non-right. It is not a right angle triangle. Okay, Pythagorean theorem doesn't work. I'm going to leave you with one question to do on your own and to bring to class tomorrow. So recall from the other day that a median is a line that joins a vertex of a triangle to the midpoint of the opposite side. Okay, so we know that definition. We know how to find a midpoint. So our job today is to determine the length of a median from a particular triangle. So got an example here. Got triangle ABC, and we're trying to determine the length of the median from angle A. So if I wanted to draw in the median from angle A, I would have to start at A and go to wherever that midpoint happened to be on the opposite side of the triangle. This point here is the midpoint of BC. So let's take a look at some process. In order to find the length of a line segment, I need 2 points. So I'm going to have to use my midpoint formula to find the second point. And then I'm going to have to find the distance from A to M, which is the midpoint, which is again another formula. And so bring this question completed to class tomorrow, and then we will continue to work on the homework.